Hello everyone. Question is, a manufacturing company uses an Amazon RDS DB instance to store inventory of all stock items. The company maintains several AWS Lambda functions that interact with the database to add, update, and delete items. The Lambda functions use hard-coded credentials to connect to the database. A SysOps administrator must ensure that the database credentials are never stored in plain text and that the password is rotated every 30 days. Which solution will meet these requirements in the most operationally efficient manner? Option A store the database password as an environment variable for each Lambda function. Create a new Lambda function that is named password rotate. Use Amazon Event Bridge, that is Amazon CloudWatch events, to schedule the password rotate function every 30 days to change the database password and update the environment variable for each Lambda function. Option B, use AWS Key Management Service AWS KMS to encrypt the database password and to store the encrypted password as an environment variable for each Lambda function. Grant each Lambda function access to the KMS key so that the database password can be decrypted when required. Create a new Lambda function that is named password rotate to change the password every 30 days. Option C, use AWS Secrets Manager to store credentials for the database. Create a secret manager secret and select the database so that Secrets Manager will use a Lambda function to update the database password automatically. Specify an automatic rotation schedule of 30 days. Update each Lambda function to access the database password from Secrets Manager. Option D, use AWS Systems Manager parameter store to create a secure strings to store credentials for the database. Create a new Lambda function called password rotate. Use Amazon Event Bridge, that is Amazon CloudWatch events, to schedule the password rotate function every 30 days to change the database password and to update the secret within parameter store. Update each Lambda function to access the database password from parameter store. Correct answer is option C. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe. Question is, a company has a stateful web application that is hosted on Amazon EC2 instances in an auto-scaling group. The instances run behind an application load balancer ALB that has a single target group. The ALB is configured as the origin in an Amazon CloudFront distribution. Users are reporting random logouts from the web application. Which combination of actions should a SysOps administrator take to resolve this problem? Select two options. Option A, change to the least outstanding request algorithm on the ALB target group. Option B, configure cookie forwarding in the CloudFront distribution cache behavior. Option C, configure header forwarding in the CloudFront distribution cache behavior. Option D, enable group label strictness on the ALB listener rule. Option E, enable sticky sessions on the ALB target group. Correct answer is option B and option E. You can download the complete list of recently updated contents from the link provided in the description. If you like this content, please like and subscribe.